Hello friends, today also we are going to start with another quote. It says statistics is the grammar of science. So today we are going to learn how to find the quartiles by folding the paper, and so we are focusing on quartiles of group data. So the main objectives of this lesson will be to calculate the quartiles through paper folding and to understand why the formula works. So before proceeding, one should know the following things like the simple calculations and the concept of quartiles to today's calculation. So for these, the materials required will be paper and a ruler. So these are the three formulas that are commonly used for finding the first, second and third quartiles. But today we are going to learn it through the process of paper folding, and we'll avoid using this formula and we will compare these results. So let's get started with an example. So the marks obtained are grouped as 0 to 20, 20 to 40, 40 to 60, 60 to 80 and 80 to 100, and number of students are there. First, take a paper, then within around the center of the paper, mark a line like this and like this through the scale. Then what you do is you measure the distances of the number of students 5, 10 and 9 like this. This is 5 cm, and then the turn comes for 10 cm, then 9 cm, then 6 cm, then 5 cm. So the remaining piece of paper will be cut with a scissor. Then what we do is we measure the distance from here. So the distance to here is 5 and distance to here is given here is 15. Then again the distance from here to here will be 15 plus 9, which is 24, and the distance to here is 24 plus 6, which is 30, and distance to this point is simply 30 plus 5, which is 35. So these values are nothing, but we call them the frequency denoted by f, and these values are nothing but cumulative frequency, which is denoted by CF in mathematics terms. So the groups that are allocated here are written below. So we are starting here from 0, so 0 to 20, then 20 to 40, 40 to 60, and 60 to 80, and 80 to 100. Now the main process starts here. First, fold the paper into half, so like this. So if you are folding, then a smaller crease will appear here like this. Again, fold the paper into half, then two creases will appear here and here. So you have already got the result as this is the quartile 1, this is the second quartile, and this is the third quartile. Now let's find the exact value. Let's bring this ruler over here. Then we are going to measure the distance from here to the first quartile. Let's look at this box, which is 3.7. Now the main idea is to find the distance from here to here, which is the first quartile. So at first we are going to find this distance, but we don't know the distance here, so we let them as x, and we find the distance from here to here is 20. Don't get confused. The same distance is allocated here as 10 and the same distance is allocated here as 20. You must understand as the upper part has a different measurement than the lower measurement. So the idea is to transfer the distance of this upper row to the lower row to find the value of x. As you can see, the upper row and the lower row are actually proportional. Hence we can write 3.7 divided by 10 is equal to x divided by 20. So we can find the value of x to be 7.4, but this is not our actual result. To find the first quartile, we need to add this distance x to this distance, so we'll get the first quartile to be 20 plus x, or 20 plus 7.4, which is 27.4. Now let's check with the formula again. So we got 27.4 as the first quartile by using this geometry or paper. Let's use the formula. So in this formula, this is for the first quartile. So the lower limit is 20. So this is the lower limit. Then n is nothing but the total frequency, which is 35. So we put here 35, and the cumulative frequency is 5 over here, and the frequency used is 10. So 10 is kept over here, and h is nothing but this distance 20. So we keep here 20 and we get it as 27.5. You may get confused why we get a different result of 27.4 and 27.5 by using the paper folding technique and by using the formula. So the reason is that, as you can see, if we have found the actual result, the distance from here to here will be not 3.7 but 3.75. But since we have used the paper folding technique and we used a ruler to measure the distance, so actually we don't have any idea to get this length in actual precision of 3.75. So we get some errors while using this paper folding technique. So what we can do is, just to make a good estimation, we can use the paper folding technique, and after understanding how it works, then we can go for the formula to find the result, which will be exact. So let's do it again to find the median or the second quartile. The same process is done. Let's look at these boxes. We use a ruler to find the distance, which is 2.5 roughly, and this value we don't know it. This distance is 20 because 60 minus 40 is 20. Since these two values, 2.5 and 9, and x and 20 are in proportion, and so we can use this formula: x over 20 equals 2.5 by 9 to get the result as 5.6. Then we can find the second quartile by adding 40 with x to get the distance from here to here. That will be 40 plus 5.6, which is 45.6. Let's use the formula again to find the second quartile. Now here we get the exact result for the second quartile, which is 45.6 by both methods. It's because we found this distance in precision, that's 2.5, with a ruler, so we got the exact result. Let's find the third quartile using the same ratio. These ratios are in proportion, so we first find the value for x, which is 7.3. Then the third quartile will be the distance from here to here, which is 60 plus x, that is 67.3. Now we use the formula to find the third quartile, and putting the values over here we'll get 67.5. As you can see also, the difference in the answer is given by the precision that we take by using the ruler. Since we couldn't find the exact measurement of this value using the ruler, so we get some errors in the third quartile, but the approximation is almost same as that of the real result. So the only purpose of this method is to involve kinesthetically, because it will help to remember things for a long time. And when we know how it works, we can easily go for the formula, and we will rarely make the mistakes in using the proper values and finding the quartiles. So thanks for watching, and keep inspiring students.